I want to welcome everyone to today's webinar. Your overhead distribution system is trying to tell you something. Are you listening? I'm very pleased to introduce you today to John Lauletta, who's the founder and Chief Technology Officer for Exactor, a Hometown Connections partner. And also joining John today is Dane Nagel, who will be working with Hometown to represent Exactor with the municipal utility market. John's a graduate in electrical engineering with Purdue University and has also done graduate work at Ohio State University. He's currently a member of the Ohio State University Electrical and Computer Engineering Hall of Fame. In 2002, John began his research at the High Voltage Laboratory at Ohio State to address the predictive maintenance issues facing the electric grid. That work resulted in a patented sensor and a strategy for grid predictive maintenance. His case studies have shown that these strategies and that technology can reduce outages due to electrical equipment failure by up to 20%. As a result of that research, he founded Exactor. And over the past 17 years, Exactor sensors have been used by electric utilities to improve reliability at the distribution and transmission level in 5 different countries, including the United States. What I like about Dane and John both is that they have a wealth of experience working with utilities. The technology is just incredible, and it has so much benefit that John will go into, but just to name a couple, obviously reliability, worker safety, and just taking care infrastructure management is just a big piece of that. So without further ado, John, I'll ask you to take control, and guys, be sure to send your questions to John as we go through the presentation. He'll be glad to address those.
Well, welcome everyone. I also wanted to just have a moment to introduce Dane Nagel. He's our municipal sales director for Exactor. Dane, why don't you introduce yourself and introduce a little bit about your history?
Sure, thanks, John. I was the utility superintendent for a small utility in Ohio, Versailles, Ohio, way back from 1999. My duties as superintendent was to manage all the phases of power, water, sewer, park, streets, refuse divisions, and I worked for Versailles all the way up till joining Exactor in 2014. We used Exactor in Versailles ourselves, and I was obviously a huge believer in the technology. I joined them in 2014, and I'm the senior reliability consultant for Exactor. I manage municipal electrical utility accounts with regard to strategic planning, with project scope, management of project processes, reporting, in-field training, and short and long-term preventive maintenance planning.
Well, welcome everyone. Again, I'm John Lauletta. My background is power. I worked at American Electric Power for a number of years, and then worked at a number of manufacturers who made products for electric utilities use. And as you heard in the intro, I opened Exactor in 2006, founded the company, and we've been working ever since to help utilities improve reliability and grid resilience. So we're going to talk a little bit about that today, how we do it, and introduce some of our techniques and premises as we go through. So Exactor works with electric utilities in transmission, doing aerial assessments of the transmission grid, in distribution, and we'll talk mostly about distribution today, and in underground in the area of cable evaluation. We work with electric utilities in a number of ways. Each utility we work with seems to have their own goal in mind, but what we do is evaluate how we can best serve the utility in meeting their goal. So when you think about all the different problems that utilities have, pole fire mitigation is one that we're really focused at this year. Reducing SAIDI and SAIFI, focusing on customer satisfaction and so on. Troubleshooting AMI connections is another one that we get involved with often where a deteriorated piece of electrical equipment will be emitting a high frequency signature, and that signature can interfere with AMI systems. And that kind of talks about how we measure things. Our technology evaluates emissions from the electric grid. And there's a lot of PD detection going on in the marketplace, but that's noise detection. And what we're doing is we're looking for specific signatures in the RF emissions in the 100 to a megahertz to a gigahertz kind of range that allows us to evaluate specific equipment. So we know we're listening to a piece of deteriorated hardware on your system as we pick it up. And we'll talk a little bit about how we introduce that in just a minute, and how we use that to locate deteriorated equipment on your grid. First, let's take a look at the premise of our approach to reliability.
The premise behind proactive predictive reliability programs is simple. By removing identifiable points of risk from your system, your grid will be less susceptible to outages and more reliable. On every system, over time, overhead components begin to deteriorate. Once the deterioration process begins, an outage can occur. Sometimes that could happen in 3 months, sometimes it could take 3 years. However, by identifying these points of risk and removing them, the grid becomes inherently stronger. Here, an area that once had 15 at-risk locations now only has 6. Fewer points of risk means your overhead is now less susceptible to outages and therefore more reliable. In addition, when storms and other major weather events blow through, the overhead system with fewer points of weakness will be less susceptible to major damage or outages, meaning your system will be more resilient too. Using the predictive reliability strategy, you will continuously reduce the points of risk on your system each year, resulting in fewer outages, less CMI, and lower SAIDI.
So the curve you're looking at right now is indicative of any kind of maintenance on your grid. So the sooner you get the maintenance done before a catastrophic failure, which is shown on the right-hand side of the graph, the lower the costs are to do that maintenance. So one of our customers had a pole fire problem that we've helped them with, and we're going to talk about in a case study in a few moments. And what they told us was, if they can find the problem on the grid and remove it before a pole fire starts, it costs them about $2,000 on average. But if they wait for the pole fire to happen and they have to rebuild the pole and accrue a whole bunch of costs with the fire department and public safety and so on, it's more like $25,000. So by doing predictive maintenance, they're able to reduce the cost of the event by a factor of 10. And we'll look at that a little bit more in detail coming up. But the great thing about RF emissions from deteriorated equipment is that it happens almost at the initiation of the deterioration. And that could be a crack or contamination on an insulator, a puncture in a lightning arrestor, an arcing turn in a transformer, a loose connection, anything that is abnormal on the electric grid and is energized will begin to create these RF emissions. The equipment failure cycle is kind of complex, and that's why it may take months or even a year for something to actually fail. But as the cycle begins, this RF emission will start. And once the RF emission starts, it doesn't typically stop, and it gets worse as the energy level of that RF emission gets worse as the equipment leads itself down the failure path. And then finally, at the end, when there's a catastrophic failure, the emission may stop at that point, but then you have other ways of recognizing that the problem has occurred, except in a flashover event. Often, contaminated insulators will flash over, and then when the lineman slams in a new fuse or closes in a breaker or the recloser recloses, the circuit will hold. And that's because once the flashover event occurs, often the contaminant is burnt right off the insulator. Unfortunately, the residue of that high temperature event makes the insulator inherently less hydrophobic, and it's going to flash over or get contaminated and then flash over again, over and over again in a cycle with more ease. So what we want to do is when that dry band arcing is going on prior to any big event, we listen for that PD emission signal and we locate that signal using our technology. So what we do in our technology is we add our sensor into a moving vehicle. For distribution, it's a ground vehicle. And as the vehicle is driving along at normal speeds, it receives that emission from the deteriorated piece of equipment. And as that reception occurs over the time that the vehicle passes, in this case, the pole with the distribution deteriorated equipment on it, the energy content goes up and then it goes down. So now we have a way to affix a location on Earth of where the emission is coming from. And that's typically about 1 out of every 100 or 150 poles. So now we can tell you to go to that 1 out of 100 poles and fix a specific piece of equipment. Now, how do we determine the specific piece of equipment? Well, we go to that 1 out of 100 or 1 out of 150 poles, and we use ultrasonic equipment to listen for that partial discharge emission. And here's an example of that equipment being used. You notice you're looking right down through the equipment like on a rifle sight.
Group number 134 cut out.
So you can kind of see as the target moved off or as the sight moved off that cutout, the noise you were hearing went away. And that noise is the partial discharge heating the air around itself and causing a pressure wave that can be picked up by the device. So now we know from 2 technologies that a piece of equipment is on your system that's going to fail. We don't know when yet, but it's going to fail sometime in the future. And you want to avoid the damage it will cause if it fails catastrophically. So what we deliver to the utility is a map of all the points of interest on your system. And that can be from our web portal, which is on the left-hand side of your screen. It's called Grid Track. Or it can be a report from Google Earth with a photograph of the device and the location photograph, so you know where to go and what to fix when you get there. This can be delivered to you if you have a GIS system in a shapefile and add it right into your GIS system, or it can simply be delivered as a paper report. So however you would like to receive it, we have methods to get it to you. The real interesting thing to us is that there's a real 80-20 rule going on here. 20% of your circuits are going to contribute 80% of your equipment-related CMI or customer minutes of interruption. And as a result, we can narrow this down to not having to look at your entire network for a project to have dramatic improvement in your indices and customer satisfaction, but we can go just to those circuits that would present themselves as the most involved with deteriorated equipment outages. And we'll look at how to do that in just a moment. So in the case of a larger utility, you may only need to have us survey and analyze 10% of your circuits. However, if you're a small utility with 50 or 100 miles of circuit, you may want us to do the whole thing, because once we're deployed, we can accomplish a lot in a very short amount of time, because the vehicles are moving at full speed, full post and speed as they move along. We can also get a group of utilities together, and we love doing that, where we go from utility to a utility. It doesn't have to be exactly adjacent, but in the same region or area. And then the whole group of utilities gets the opportunity to experience predictive maintenance strategies at a very low cost because they're sharing in the entire program. This is a web app that we developed so we can show people who are going to take the course of a portion of their grid to be evaluated. And we can take data from your knowledge of circuit outages that are equipment related. We don't want all circuit outages, just the equipment related ones, or the unknown ones, because that could be possibly equipment related activity. And we can use that to build strategies for you. If you look at the bottom of this page, the predictive program overview, you can see that for this customer, we developed 3 individual strategies. One of doing 10% of all their miles, one of doing 16%, and one of doing 24% of all their miles. We call that the attack profile. Again, if you're a small utility with 100 miles or less, you may just want to do your whole system. And in each of these cases, you can see that the highest ROI is doing the 10% program, because those are the cherry-picked circuits that are the absolute worst circuits for equipment-related issues on your grid. In one Midwest utility, we found that in our project, we prevented 47 power outages by helping the utility find things that were in trouble of failing and causing an outage. But the big news is we reduced for that year their projected CMI by 240,000 minutes. That's customer satisfaction. We reduced their SAIDI by 3.5 minutes for their entire company. That includes all outages, including vegetation and everything else. And we saved over $280,000 of operating costs for the utility, and saved the customers, based upon the DOE ICE calculator, almost $500,000 by avoiding their involvement in having a power outage. So I wanted to talk a little bit about some case studies now that are really interesting. The first case study comes from Unitil. Now, they're an investor-owned utility, but a small one. They're in New Hampshire. And they went to their Public Utility Commission and said, look, we've been trying to improve, as you've asked us, in our customer satisfaction and reducing outages and so on. And we just run out of ideas. So we found Exactor. They have a new approach to getting the work done and finding new opportunities for us to improve our circuits operation and performance by using predictive maintenance tools. And they were able to partner with their Public Utility Commission, where the Public Utility Commission said, okay, we'll let you do this and we'll let you recover the costs of doing it, but you need to come to us every year and explain what you did and how it affected your system. So in the first year of 2013 of our multi-year program we've had with them, we found 62 problems on their grid. They replaced all of them, and they got a reward from doing that of about 1.2 million customer minutes of interruption avoided, which is a direct customer satisfaction improvement. In 2014, the next year, we found 58. And as we go on and on throughout this program, it gets better and better each year. So you might say that the savings is going down, but the problems are going down as well. So then we start looking at other attributes of predictive maintenance. And one of the biggest ones is worker safety, because every problem you find that you can schedule for on normal time repair is a problem that is safer for the workers to work on. Think about it. If a transformer catches fire at night, or an outage occurs at night. Now you've got workers in the dark trying to get their work done under emergency conditions. Wouldn't it be much better if they could do that work during the day? And wouldn't it be much safer for them to avoid darkness and trips and falls and things like that happen when it's dark out? So this is a real success story. It was written up in T&D World Magazine. This is a very interesting program because it shows the power of the analytics that we acquire while evaluating your grid. So when we come to your utility to begin the process of developing a program for you, and one to meet your budget and one to meet your goals, we pretty much know what we're going to find because we've been doing this for 17 years. And we know from region to region in the country what we're going to find by percentage. And in this case, at this project at a co-op called CoServe, we did a big program, and we expected to find about 10 to 12 lightning arresters, and we found 30. And right away, that told us something is wrong here. The statistics can't be that bad from our projected findings to what we actually located. And it turned out that 20 years previous to our project, they had replaced all their lightning arresters and had done nothing with them since then. And in our program, we found lightning arresters that had blown their ejectors. We found lightning arresters that were still connected, but they weren't going to protect anymore because their MOVs had been punctured and so on. So we went back to them and explained this to them. Well, they immediately ordered us to go off and look at the rest of the grid. And we found 100 lightning arresters that weren't going to be able to protect the downstream equipment anymore. So they replaced all their lightning arresters again and brought their system back to normal operating conditions and normal performance. This is a real interesting municipal study in the West. This utility has had a real specific problem. They have they have 228,000 customers, so about 5,000 miles of grid, and that's an estimate, but that's probably pretty close. And on 200 miles of this grid, they had this problem of pole fires. Now, this is a perfect engineering study, the kind of study every engineer loves to get his hands on, because for 10 years in the past, they've had 8 to 12 pole fires on this 200-mile segment of their lines every year, and consistently. And so we had now a historical record of what was going on, so we could tell the outcome of what we would accomplish for them. So we assessed those 200 miles, and we found 65 pieces of equipment that were problematic, deteriorated in some form or another. And it turned out most of it was contamination, and these 200 miles were near a large airport, and so it was probably airport air fuel contamination on those insulators that would build up over the years. So they replaced those 65 components, and for the next 30 months, they've had no pole fires on that section of their system. And now they're coming into the new pole fire season rather. But I want to take you back to that estimate that they gave us when we started working with them. They said that if they could replace a component on a pole, these were all three-phase poles, it would cost on the average about $2,000. But if a pole fire occurred, it was more like $25,000 to recover from that event. So in the 3 years they've had no pole fires, they've avoided $250,000 worth of planned pole fire response for that period, or for the 3 years, $750,000 of avoided cost to that utility. So and that doesn't account for all the other collateral damage that may occur when you have a fire event. So, I mean, to me, that's just a tremendous demonstration of the power of using analytics about your grid rather than waiting for something to happen or trying to use other technologies like visual or IR as your only tools to maintain your grid. And they had done that, of course, over those 10 years of repeated problems. You may not know the city of Orrville, Ohio, but you probably really do, because there's a big company in Orrville called Smuckers, and they make all their jelly and jams there, and peanut butter. So the city of Orrville is really focused at reliable operations, reliable service, both to their customers, their residential and commercial customers, but to these large industrial customers as well. Well, they're not a very big utility. They only have 260 overhead miles, 7,000 customers, but Smuckers is one of those customers. So it's very important to them that they keep a reliable system running. And in our project, we found 21 locations after we analyzed about 40% of their city's grid. And 2 of those findings were lightning arresters that could, if they didn't protect downstream equipment, could have really affected their industrial loads. So they are very pleased with what we found there. This is a real quick demo on how we can deliver our data to our customers in a web-based portal that doesn't require any software to be loaded at your home system.
Here's how you'll probably use GridTrack. You will view your finding. To get more granular data about that finding, you will double-click like this. The main observation window will pop up where you can view the information. Here you can see address, GPS location, and type of equipment found. And even view the actual component that is emitting the partial discharge by clicking this. To see the product closer, you can click again, and there it is, larger. The next thing you will probably want to do is see the location. To do this, simply click the finding that you're interested in and drag it to the geo side like this. And voila, there it is. Want to see a satellite image of the area to see if it's a remote place, neighborhood, or industrial park? Simply go up here to Maps. You will have a choice of views. I will choose this, satellite. I can even move the view back to see if there are other problems nearby. Or I can move it closer to see the terrain. View GridTrack data by circuit number, city and street, pole number, or by the type of problematic equipment discovered. You can even drill down and see a photograph of the deteriorating equipment. And when available, a field video of the ultrasonic confirmation of the problem can be provided and viewed from GridTrack.
We have a lot of customers, large and small, and one of our real hallmarks for our company is working with AMP partners, and they're a group of municipals in Ohio, Michigan, Pennsylvania, and Virginia, and we've worked with all of them, and we've created programs where groups of utilities can get together and have results, as well as some of the larger utilities can have their own programs. But it's just been a great association, and we'd love to do that with you and other Hometown Connection partners. Now, to do an evaluation of your utility, if you're a small utility with less than 100 miles or 100 or so miles, it's probably best just to get our basic program, and we just do your whole system for you. If you're a larger utility with, say, 1,000 miles or more, you may want to have us come in and do an analysis of your system. And the data that we get is data about outages on your circuit. So this is just one circuit with an outage result and description of that circuit. And that's the kind of data we use to do a Pareto analysis of all of your circuits and tell you the 10% or the 15%, which would give you the best result in doing a program with us and minimizing the amount of maintenance on your part that you would have to accomplish to achieve a result that would meet your goals. Now, if you don't have this data, it doesn't matter. We can work with you anyway. But if you have the data, we can just fine tune our presentation of project for you. So it's up to you now just to get started in this world of analytics. Dane and I are available to you to help at any time. This presentation has been recorded and is available to you. And if there's any questions, you could either just jump on and ask a question or put it in the chat box, and I'll be happy to answer those for you.
John, I had a question. This is Mike Mazingo with Hometown.
Sure.
I know we've got a couple. Well, we may have gone past our time, but real quick, I know a lot of utilities are facing some issues with supply chain, and I'm just wondering how a predictive program helps alleviate some of the issues that our municipal utilities are facing with that.
Sure, yeah. That question came up earlier today too in our first presentation. Supply chain's hard on everybody still, and it's going to be hard on us for all of us for a while. But when you do a predictive strategy, you know what you need to buy throughout the year to mitigate the issues that you're dealing with. And since these problems do take time to manifest themselves, predictive information is the earliest warning of a problem to come. And so now you have time to work on that. Many of our customers do a program in the first quarter of the year and then use Q2 and 3 to do the field maintenance. And also, if like that one utility who found out they had to buy and replace a lot of lightning arresters, now they know and to put in larger orders than normal for lightning arresters for next year. So these kinds of analytics are very powerful in a number of ways. The one that I think is most important, the way to use these analytics, is to get your line workers out of doing emergency work and doing scheduled work and improving the safety of their job, because of course they have one of the most dangerous jobs in industry. So anything we can do to help with that is a real important thing.
Yeah, thank you, John. Well, if there are no further questions, I want to thank John and Dane for their time today, and for Mike and Brian and others who joined us today. We really appreciate it. And we will be making this recorded session available to our municipal affiliates and let them pass it on to their members.
Thank you so much, everyone.
Yes, thank you.
Thank you. Have a great afternoon.